This begins Chapter 4, Lesson 1, dealing with the distributive property. So let's go over Chapter 3 and see how much you remember. We're going to take 3 and 3/8 and write that as a decimal. Is it A, 3 and 83 hundredths, B, 3 and 38 hundredths, C, 3 and 375 thousandths, or D, 3 and 3/10 repeating? And your answer is? Now we're going to write a negative 5 hundredths as a fraction in its simplest form. Is it A, negative 1/20th, B, negative 1/5, C, 1/20th, or D, 1/5? And your answer is A. Now we're going to solve 2/3 x is equal to 8/9. Now remember, when you go ahead and solve these, to get x by itself, you're going to multiply each side of your equation by 3/2. So does that give you A, where x is equal to 5 1/3, B, x is equal to 1 1/3, C, x is equal to 2/9, or D, x is equal to 1/9? And your answer is? Now we're going to solve n minus 3/4 is equal to 1 1/2. Does n equal A, 3 1/2, B, n is equal to 3 1/4, C, n is equal to 2 1/2, or D, n is equal to 2 1/4? And your answer is? Now in a survey of students, 13/25 of girls and 11/20 of boys have a pet. Does a greater fraction of boys or girls have a pet? So in other words, they're comparing these two fractions. You're going to need, I would convert them both into decimals to see which one is the greater. So do A, boys have a greater fraction of pets, or B, girls, or C, are these two fractions equal? And your answer is? Boy. More boys have pets than girls. Now Tony used 3/4 yard of brown fabric, a 1/3 yard of yellow fabric, and 2 1/6 yards of beige fabric to make a dress. What is the total amount of fabric? Now make sure that when you're dealing here, you're adding 3 fractions with unlike denominators. So you're going to want to make sure that you convert them so that they all have the same denominator. Is it A, 2 yards, B, 3 1/4 yards? I'm sorry, B is 2 3/4 yards, C is 3 1/4 yards, and D is 3 5/12 yards. And your answer is? So we've already been evaluating numerical expressions using addition and multiplication. Now what we're going to do is we're going to use that distributive property to write equivalent numerical expressions. And then we're going to take what we've practiced with using just numerical expressions, we're going to apply that to algebraic expressions as well. So an equivalent expression is just two expressions that have the same value, but maybe are said it in a different way. Two examples of equivalent expressions would be 8 times 3 and 6 times 4. They both equal 24. Then the distributive property is where we use parentheses and we multiply by a number for each addition problem within the parentheses. I know that's probably not the best way to go about explaining it, but you'll see an example of it and it'll explain it way better than anything I could do. And here it is. So when you see the distributive property, you're going to multiply a sum or a difference by a number. You're going to multiply each term inside the parentheses by a number outside the parentheses. So an example, you have 5 times the quantity 6 plus 7. That is the same as 5 times 6 plus 5 times 7. And I'm sure some of you are saying, but wait, Mrs. Treasury, I thought you said using the order of operations, we have to do what's in parentheses first. And to that I would say yes. But now look at what happens when we don't know all the numbers. So in the example of A times the quantity B plus C, we don't know what A, B, and C equal, so we can't add B and C together. But we can multiply A times B plus A times C. And the same thing with the subtraction symbol. Whatever's on the outside is going to get multiplied by whatever's on the inside, by each term. So it's just one way to simplify an expression, especially when we don't know the value of some of the variables. So now we're going to use the distributive property to write 4 times the quantity 5 plus 8 as an equivalent expression, then evaluate the expression. So what I'm going to do is I'm going to multiply 4 times 5 plus 4 times 8. I am going to multiply those two, so now I am left with 20 plus 32, and it equals 52. Now I know that you're sitting there thinking, but Mrs. Treasury, I can add 5 plus 8 and get 13 and do 13 times 4. And that's so much faster. I'll still get the same answer. And to that I say, you're right. But practice using the distributive property, because a time is going to come in this lesson where you don't know what one of those numbers are, and you're going to have to multiply them out. So humor me and practice actually using the distributive property. Don't just write that it equals 52, because really, then you're not really using your brain to your full potential. Now we're going to use the distributive property to write 6 minus 9 times the quantity 6 minus 9 times 2. Sorry, I had a problem reading that. We'll write that as an equivalent expression, then evaluate the expression. So we're going to take 2 times 6 minus 2 times 9. That's going to give me 12 minus 18. And when I subtract that, I'm going to get a negative 6. Yes, if you plug this into your calculator, it will give you the answer. But if you're not using the distributive property, you are just doing busy work, and you're not actually learning what you need to learn. And then you're going to come to me confused, and the work that you put into this is the work you're going to get out of it. So now use the distributive property to write 3 times the quantity 9 plus 2 as an equivalent expression. Then evaluate the expression. Is it A, 3 times 9 plus 3 times 2 is equal to 30? Is it B, 3 times 9 plus 3 times 2 is equal to 33? Is it the quantity 3 plus 9 times the quantity 3 plus 2, which is equal to 60? Or is it 3 times 9 plus the quantity 3 times 2, which is equal to 72, sorry. And your answer is? So now we're going to use the distributive property to write 10 minus the quantity, let's try this again. The quantity 8 minus 10 times 3 as an equivalent expression. Is it A, negative 6, B, 6, C, 14, or D, 54? And your answer is? Now, Community Center offers canoeing day trips. The canoeing fee is $80 per person. The cost of food is an additional $30 per person. Find the total cost of a family of 4. So if we take 4, because we know the cost of fee per person and the cost per food, we need to find the total cost for a family of 4. So we're going to use the distributive property. So we're going to take 4 times the quantity, 80 plus 39, which is the same as 4 times 80 plus 4 times 39. And we go through and we solve that using the distributive property. We get 476. And so that is the total cost for a family of 4. So now the cost of a movie ticket is $7, and the cost of a box of popcorn is $2. Write 2 equivalent expressions to find the total cost for a family of 5 to go to the movies if each member of the family gets a box of popcorn, and then find the total cost. So, is it A? Is it B? Is it C? Or is it D? And your answer is? So now we're going to do some simplifying algebraic expressions. This is why you need to practice the distributive property in previous. This is why I spent a lot of time talking about why you do the distributive property in previous examples. Because here we're going to use the distributive property where we don't know one of the numbers, so we have to use variables. So now we're going to take, same thing applies, we're going to take 2 times x plus 2 times 4. We're going to multiply what we can multiply. And so our equivalent algebraic expression is 2x plus 8. And that's just all the farther that we can do with it. So now we're going to do the same thing here. We're going to take the distributive property to take the quantity y plus 3 times 6 as an equivalent algebraic expression. So we're going to take 6 times y and 3 times 6. Add them together, we get 6y plus 18. And that is our answer. All right, so try this one. We're going to take 4 times the quantity m plus 7. Using that distributive property, rewrite it as an equivalent algebraic expression. Is it A, m plus 28, B, 4m plus 11, C, 4m times 28, or D, 4m plus 28? And your answer is? Now we're going to use the distributive property to write p, the quantity p plus 3 times 5 as an equivalent algebraic expression. Is it 5p plus 8, C, 5p plus 15, C, p plus 15, or D, 5p times 15? And your answer is? Now we're going to use the distributive property to write 4 times x minus 2 as an equivalent algebraic expression. Nothing is going to change whether we are using addition or subtraction. Just kind of pay attention to what you're doing here. When we look at this, we have 4 times x times 4 times a negative 2. So we're going to be left with 4x minus 8. And they rewrite this with the plus sign just so that you recognize that you're dealing with a negative number. And you just don't lose that negative number, because that subtraction does mean it means the same thing as a negative number. Now we're going to use the distributive property to write a negative 2 times the quantity n minus 3 as an equivalent algebraic expression. Now they have you rewrite it with a n minus 3 as n plus a negative 3, and that's just to make it a little easier when you go ahead and multiply across. You don't necessarily need to rewrite it that way, as long as you can keep track of all your negative signs. So now you have a negative 2n plus negative 2 times negative 3, which gives you a negative 2n plus 6. So that's our answer. Now we're going to use I want you to use the distributive property to write 2 times the quantity a minus 6 as an equivalent algebraic expression. Is it A, 2a plus 18, B, 2a minus 18, C, negative 36a, or D, 2a minus 7? And your answer is? Now try this one. Using the distributive property, I want you to write a negative 7 times the quantity b minus 3 as an equivalent algebraic expression. Is the answer A, negative 7b minus 10, B, negative 147b, C, negative 7b plus 21, or D, negative 7b minus 21? And your answer is C. If you thought it was D, it's because it is negative 7 times negative 3, and that gives you that positive 21. And that